right, welcome to our Unit 11B Day 1 notes. So we're working on volume this unit. So today we're going to talk about the volume of cylinders and other prisms. So first of all, volume is the measure of space occupied by a solid. So we typically say like inches cubed or feet cubed. And that's how much space a solid contains. Now, any three-dimensional figure can be created by taking a two-dimensional figure and rotating it around a specific axis or line. In this case, what about side W with a rectangle? Well, if you take the side and you continuously rotate it around that axis, you've got to envision that this would go like into the page, come out of the page, and would create a circular base. Likewise, the same thing would happen in the bottom. So it'd look something like that. So by taking a rectangle and rotating him around W, we have created a cylinder. Now, in real life, we could think about this as a rotating door. All right, so here's a visual representation of what I mean. So I'm sure you guys have all at some point worked or been through a revolving door where you push the glass panel to get it to rotate around. That glass panel is in the shape of a rectangle. So as that rectangle gets continuously pushed around, you can see it is a cylinder shape. So our three-dimensional figure. So as discussed last unit, we know about different shapes of prisms. So a square prism, a triangular, and a cylinder, and they're all named based on the shape of their base. So the volume formula of any prism is capital B times H, where capital B is the area of the base. H is your height of the prism. And as we discussed last unit, height of the prism I like to think of is the distance between our bases. All right, so for instance, if we have a square prism, the base area would be side squared. If it's a triangle, we probably would use 1/2 base times height. And if it's a cylinder, a circle has an area of pi r squared. All right, so starting with our most basic shape, we have a rectangular prism. I'll just write it like that for now to get it to fit. So rectangular prism. So the base, we'll say, is what it's sitting on. Technically, that's not always the case, but with a rectangular prism, we have a bit of freedom there. So the area of the base, which is a rectangle, is just 5 times 9. Which, as we know, is 45. So 45 units squared, technically. Now, if volume is area of the base times the height, that's 45 times our height of 6.5. And if you were to type that in your calculator, we would get 292.5. Now, since this is volume, it's centimeters cubed. Now, with a prism, you've probably heard this before, too. Volume of a rectangular prism is length times width times height. And that length times width, length and width, is actually coming from the area of the base. Okay, so you'll see that, or probably have seen that before in the past. That is, again, the same thing as area of the base times the height. All right, our next guy that we're looking at is our triangular prism. Where, again, our base is a triangle. Now, capital B is super important to know. That's the area of your base. That's 1/2 little b times h. Now, in this instance, little b is the base edge of your triangle. So our base edge of that base is 6. And the height is the height of the triangle, or the altitude of the triangle, which is 7. So 1/2 of 42 would be 21. Okay? Now the distance between the bases is 10. So if volume equals area of the base times the height, we've got 21 times 10, so 210 inches cubed. And that's the volume of your triangular prism. Moving on to the next page. All right, well, the base looks like a trapezoid, so that means we are looking at a trapezoidal prism. So again, I'll figure out the area of the base first. Now, the area of a trapezoid is base 1 plus base 2 over 2. It's the average of your bases times the height of the trapezoid. Now, again, for the area of the base, you're only looking at that trapezoid. Don't look anywhere else, okay? The bases are 2 and 4. The height of the trapezoid is 1.5. So multiply that all together and we'll end up with 4.5. All right, so once we have the area of the base, the rest of this is pretty easy. Volume, again, is area of the base times the height, or 4.5. Height, again, distance between the bases is 6. Multiply those together, and we would get 27 centimeters cubed. All right, our very last shape here is a cylinder, because he has a circular base. I know the base, since he's a circle, is pi r squared, and they have the radius listed for me, which is 6. So in exact form, this simplifies to 36 pi. Make sure you don't lose the pi on that. All right, I know volume is area of the base times the height, so 36 pi times our height of 20 feet. And in exact form, we would get 720 pi. So I'll just put a little note here. That's our exact volume. But if we wanted rounded, remember we type that in our calculator with the pi, and we would get 2261.9 feet cubed. All right, so question 5. Find the volume in feet cubed of a rectangular prism whose dimensions are 3 feet, 30 inches, and 54 inches. Now, since it's said in feet cubed, we want feet to begin with. So notice how 2 things are in terms of inches. Now, if there are 12 inches in a foot, then what we would do is take each of these and divide by 12. So 30 divided by 12 is 2.5, so 2.5 feet. 54 divided by 12 is 4.5 feet. Okay, so now that I have everything in terms of feet, okay, a rectangular prism, I can do length times width times height. And it technically doesn't matter whose length, width, or height. You're just going to multiply them all together. So we're just going to do 3 times 2.5 times 4.5, and we will get 33.75 feet cubed. All right, so not too bad, just a little bit of conversions. Just remember you always convert first. All right, question 6, determine the volume of the following to the nearest hundredth. Now, first thing I'm noticing is I don't know the height, but I spy with my little eye a right triangle. I can do the Pythagorean theorem and find the height of this and then get to my volume formula. So a squared plus b squared equals c squared. I'll do 11 squared plus h squared equals 14 squared. Now that's 196 minus 121, so h squared is 75. And then I'll just leave this as radical 75 for now. No point in doing a decimal just yet. Now again, we know the base is a circle, so that's pi r squared. Be careful, the radius is not 11 though, the radius is 5.5. They gave you the diameter in that problem. So that means the area of our base will be 30.25 pi. Now volume is area of the base times the height. Okay, the height we just found was radical 75, and then we type that in our calculator. Okay, so 30.25 pi times radical 75 will give us 823.01 inches cubed. All right, question 7. If the exact volume of a circular cylinder is 36 pi kilometers cubed and its radius is 2 kilometers, find its height. Well, as we know, volume is area of the base times the height. And they're telling me the volume is 36 pi. Make sure you don't lose the pi there. Now the base is pi r squared, right? Because they're in a cylinder. They told us the radius is 2. Okay, so ultimately what I need to do is take 36 pi and set him equal to 4 pi h. So in order to solve for h, I would have to divide both sides by 4 pi. Pi's would cancel. 36 divided by 4 is 9, and that is the height. All right, next problem. The volume of a hexagonal prism is given. If the height is 6.4, what is the area of the base? Now keep in mind, this is slanted off to the side, so as we discussed last unit, this is called an oblique prism. And again, we know the volume of any prism is area of the base times the height, and that's actually the same as if it was an upright prism versus an oblique. They gave you that perpendicular height right here of 6.4. The volume is given. So again, if I'm solving for the area of the base, they're just asking me what capital B is. So this is actually a super easy problem. We'll just divide both sides by 6.4. And our base will be 17.3 centimeters. Now technically it's centimeters squared because we're talking about the area of the base. All right, question 9. Find the volume of an oblique cylinder. So oblique again means it's just like slanted off to the side like that. That has a radius of 5 feet and a height of 3 feet. So one little tick mark there means feet. Round to the nearest tenth of a foot. All right, so again, volume is area of the base times the height. So if you want, you can even jump to this step. We know the base is a circle, so you could put pi r squared in for area of the base. We know the radius is 5 and the height is 3. So as an exact form, that's 75 pi, right? But make sure you pay attention to your rounding. They want me to do tenth of a cubic foot. So I'd have to type 75 pi into my calculator, and I'd end up with 235.6 feet cubed. All right. So I think I'm going to skip question 10. We'll save that for a future problem. I want to look at question 11 here about my can. All right, a can 12 centimeters tall, so that's this whole distance, 12 centimeters tall, fits into a rubberized cylindrical holder that is 1.5 centimeters tall, as shown in the diagram below. The thickness of the rim of the holder is 1 centimeter. So guys, this distance right here, 1 centimeter. Including 1 centimeter of thickness at the base of the holder. So that's down here. All right, so what is the volume of the rubberized material that makes up the holder? Okay, so ultimately, guys, you got this can that's in a cylinder shape that's in what you guys would probably call a koozie. Okay, so those are the things that you hold your drink in so that your drink remains cold so that the heat of your hand doesn't touch the drink. All right, I think we know what we're talking about. Now, the whole part about a 12 centimeter can fitting in it is irrelevant to the volume of the shape. It's not like the taller the drink you put in, the more volume the koozie has. Like, that's ridiculous. So this whole 12 centimeter can tall thing is actually unimportant. Okay, so I'm even going to just cross it off from my little diagram here or erase it. Okay, if I want to figure out the volume of the koozie, which is what wraps around our drink, there's ultimately a cylinder that goes around the outside edge. Now, if I find the volume of that cylinder, that would be the volume of the whole cylinder, right? That would be if it was completely solid, but it's not completely solid. It has a hollow part in the middle that you're able to fit the drink in. So ultimately, we have two cylinders here. We have the larger cylinder. So I'll kind of do him in blue, I think. So that's like my outer figure. And then I'll do this in red. I have the smaller cylinder. So I'll put them over here. So ultimately, I'd want to find the volume of each of those, but then take the difference so that I have the volume of just the rubber around the outside. Okay, so let's start with our bigger cylinder. All right, so a couple of things we would need. We need the radius, which it looks like, actually, you know what? Let me start with the smaller one. I think this will be easier. They told you that this is a 6 centimeter opening for the can, which means that the radius is 3. Okay, now you got to be careful. There's rubber at the bottom of this. So even though this rubber is 1.5 centimeters tall, just in here is 1 centimeter short of that. So this is 10.5 centimeters tall. Okay, now let's look at the blue one. So the blue, which is our big outside cylinder, has a height of 11.5 centimeters. Okay, but the diameter was 6 inches across here, but they added an inch on either side for the thickness. So 6 plus 1 plus 1 is 8 centimeters, which means the radius is 4 centimeters. All right, so we're all set up to go. So again, I know volume is area of the base times the height, or pi r squared h. So I'm just substituting in some of my info here. I'll do the same thing for my smaller cylinder. All right, so that's my setup for each of those. Let's see if I can pull up my calculator. All right, so what I'll do, let's figure out each of those. So I've got pi times 4 squared times 11.5. Oops, I need an 11 in there. All right, so that's the volume then of my outer figure. Now let's do the same thing for our inner cylinder. So the radius is 3, but the height is 10.5. All right, so 578 number, 296 number. Okay, now again, we got to take the difference to figure out the shape of just the rubber. So what I'm going to do, let's go up and copy paste this. Notice how I haven't rounded yet. This minus that. Hit enter, and I get 281.172. So to the nearest hundredth, we are looking at 281.17. And that is the volume of the rubberized cylinder. All right, so I actually changed my mind. I'm going to go back up to the question I skipped and just do that one. But I wanted to make sure I hit up this one first because this one's more complicated in my opinion. All right, so, by the way, that looks like a pi. That's supposed to be a 1/7. There we go. All right, question 10. All right, so we're in a sandcastle competition. Contestants are allowed to use only water, shovels, and 10 cubic feet of sand. To transport the correct amount of sand, they want to create cylinders that are 2 feet tall to hold enough sand for the contestants. What should the diameter of the cylinders be? Round to the nearest tenth of a foot. All right, so let's draw a picture so that we can organize our information. They say they're using cylinders to transport the sand. So let's draw a cylinder. Okay. The cylinder is 2 feet tall. And it says that there is a volume of 10 cubic feet. Now they want me to find the diameter, which is twice the radius, as we know. Okay, so let's start with what we know. They're giving us information about the volume. Again, we know volume of any prism is area of the base times the height. So we're going to do volume is 10. We don't know the area of the base, but we know the height is 2. Divide by 2, that means our base area must be 5 feet squared. Okay, great. So then we know that the area of that base, which is pi r squared, must then be set equal to 5. All right, so in order to solve for the diameter, we're going to need the radius, okay? So first thing I do is divide by pi. So I'll leave this as 5 over pi for the time being, equals r squared. Now in order to solve for r, we'd have to take the square root. And we'll obviously get a decimal here. All right, let me grab my calculator again. So we're doing square roots of 5 divided by pi. So we get this 1.26 number. Again, do not round. They don't want the radius though, right? Don't they want the diameter? So we're going to multiply by 2 in order to get the diameter. So take my unrounded answer, multiply by 2, and I get this 2.52 number. Now, that's my diameter, but it doesn't want this as 2.52. It wants the nearest tenth. So final answer, diameter would have to be 2.5 feet in order for our cylinder to be able to contain the appropriate amount of sand for our sandcastle competition. All right, so that concludes our volume notes for day 1. So again, big takeaway here, volume of any prism is area of the base times the height. And also just make sure that your units are in the appropriate dimensions for what you want. So like for instance, when I scroll back here in our notes where I'm going to put a star next to number 5, where they have mixed units like feet, inches, inches, you guys need to make sure you go back and say, oh, but it wants feet, and then do the conversions first. Do not do them after, otherwise you will get the wrong answer. All right. That concludes our video.